Hello, welcome back to Mass Transfer 1. So you all know that we have finished the first three units of the course. So today I'm starting the fourth unit, so which is about the methods of distillation. So since this is our first session of the fourth unit, so let me just take you back to the course objective. The objective of teaching this course is to make the student summarize the principles of various mass transfer operations used in industries and know their applications. And this is the course outcome a student should attain at the end of the unit number 4, that is methods of distillation. So after having gone through the course in this particular unit, the student will be able to classify the different methods of distillation and also will be able to explain their principles and will derive Rayleigh's equation and also illustrate the McCabe-Thiele method for finding out the number of theoretical stages to carry out the continuous distillation operation. So also you'll be able to solve a few problems connected with the types of distillation. So these are the contents which we are taking up today. So this is one session where we are discussing the fundamentals of the methods of distillation. So first we'll learn what are the different methods of distillation that have been followed in industries. So one type of distillation, that is equilibrium distillation, which is also called as flash vaporization, will be taken up today. So you are going to understand what is meant by flash vaporization and what are the principles involved in the operation. So and how you can carry out the flash vaporization. So then we'll derive the equation of operating line for this particular type of distillation, and using the equations derived we have to solve a few problems on this type of distillation. The different methods of distillation are classified under the two categories as follows. The first category involves two types of distillation methods, so in which the production of vapor is done by boiling the given liquid mixture, so from which you have to separate the components, and the vapors are brought into equilibrium with the liquid phase, and afterwards the vapor is separated and condensed, and that condensed liquid is taken out as a product without allowing any of that liquid to return to the still from which the vaporization is done to contact the vapor. So such method of distillation are either equilibrium distillation, which is also called as flash vaporization. Then we have simple distillation, which is also called as differential distillation. So equilibrium distillation or flash vaporization may be a batch operated or a continuous distillation, while the simple or differential distillation is a batch distillation. So this is the first method of distillation. In the second method, the condensed liquid will be divided into two parts, and one portion will be sent back to the still under such conditions that the liquid will be brought into intimate contact with the vapors on their way to condenser. So that is done in order to make the vapor more and more rich in more volatile substance. At the same time, the liquid will become more and more rich in the less volatile substance. So that second method is called as rectification or fractionation. So that is the classification of distillation methods. So we have now three distillation methods to study. One is the equilibrium distillation, other one is simple distillation, and finally we are taking up rectification or fractionation. So what is equilibrium distillation? A flash vaporization or equilibrium distillation is that distillation operation which is actually a single stage operation in which the liquid mixture is partially vaporized and the vapor will be allowed to come to equilibrium with the liquid phase, and the resulting vapor and liquid phases by that contact are separated and removed from the apparatus and taken out as products. So such a distillation operation is called flash vaporization. So this is one operation which is equivalent to one stage operation, and it can be carried out in a batch-wise manner or in a continuous method. So this is how basically we carry out the flash vaporization. So the flash vaporization or equilibrium distillation consists of three steps. In the first step, we vaporize the definite fraction of the liquid. That means out of the given liquid, some portion will be vaporized, and that vapor phase, after it attains the equilibrium with the liquid phase, will be separated out from the liquid, and the vapor phase will be taken to a condenser where it is condensed and taken out as the overhead product. So the apparatus required to carry out this kind of distillation is like this. So first the feed mixture will be taken to a heater because we need to vaporize the given solution partially. So after heating the mixture, it is passed through a wall where its pressure is reduced so that it flashes into vapor partially. That is, adiabatic evaporation takes place where a portion of liquid gets vaporized. Now, after passing through this throttling valve, it is a mixture of vapor and liquid that will be fed to a separator which is of cyclone type. Okay, so this will have a annular space here. The mixture of vapor and liquid will be fed to this annular space, and due to centrifugal force, the liquid will flow against the wall, along the wall, and comes to the bottom of the separator, while the vapor will come to the center of the separator, and from there it flows in the upward direction, finally comes out from the top of the separating vessel. So this vapor from the top will be taken to a condenser where it is liquefied and collected as the overhead product. The whatever liquid that is separated in the separator will be collected at the bottom, from which it is withdrawn, and this one fraction is the bottom product of the operation. So that is how we can carry out equilibrium distillation. Okay, so this is a simple flow diagram showing how equilibrium distillation is carried out. So the feed is entering a heat exchanger here, so where it is getting heated to certain temperature, and that hot solution is passed through this wall where its pressure is reduced to convert it to a mixture of vapor and liquid. The vapor and liquid mixture will be fed to this cyclone type of separator and into the annular space, and when it circulates in the annular space, the liquid will be thrown against the wall and flow against the wall and finally comes to the bottom. So whereas vapor from here flows in the upward direction, and from the top outlet it is taken out to a condenser where it is condensed and collected as a distillate or overhead product. The liquid from the bottom is another product called bottom product. Now let us perform material balance operation for this flash vaporization. So this is a typical flow sheet showing you how flash vaporization is carried out in industries. The liquid feed is heated in this tubular heater. Then pressure is reduced by means of a valve where vapor is formed at the expense of the liquid. That is, some portion of liquid flashes into vapor. So hence it is called as flash vaporization. The vapor liquid mixture will be then introduced into the vapor liquid separating vessel of cyclone type as shown in the diagram. So as the feed enters tangentially into the covered annular space, this is the covered annular space to which the feed enters at a certain velocity. So due to the centrifugal force acting on the contents, the liquid will flow along the wall and leaves from the bottom. So while the vapor rises through the central chimney and finally leaves at the top to be taken to a condenser where it will be liquefied. So now let F moles per hour of feed enters the distillation operation. So let F be the kilomoles of feed consisting of A and B components, where A is the more volatile and B is the less volatile component. So these notations and assumptions you already know. So throughout our discussions, we are considering the binary mixture of A and B. So let XF be the mole fraction of more volatile component in feed. So also let then D moles of liquid is obtained by condensing the vapor from the top of the separator. So this will have a YD star amount of mole fraction of more volatile component in the vapor. So assume the composition of the top or overhead product be YD star. In the same way, let us assume the notations for the liquid coming out from the bottom. So W moles per time is the liquid coming out from the bottom, which has a composition represented by XW. So XW is the mole fraction of component A in the bottom product. It is whatever liquid that is coming out from the bottom. So using all these notations, let us perform a material balance. Okay, the overall material balance is, so F is equal to D plus W. So total amount of feed enters here as F kilomoles. So that will be separated into D moles as vapor and W moles as liquid. So F equals D plus W is the overall material balance equation. Then the material balance equation for component A is given by F into XF is equal to D into YD star plus W into XW. So multiplying mole fraction with the total quantity of the material in moles will give you the total moles of A present in that particular stream. So FXF will give you amount of A present in the feed stream. Then DYD star will give you the quantity of more volatile component A present in the overhead product, and WXW gives you the moles of A present in the bottom product. So let these two equations as equation number 1 and 2. So from equation 1 we have F is equal to D plus W. So let us substitute that in the equation number 2. So in the equation number 2 on the left hand side we had Fxf. So that F has been replaced by D plus W from equation number 1. Now let us simplify this equation. So here it becomes dxf plus wxf. The right hand side remains as it is, dyd star plus wxw. So let us shift all the d terms to one side and all the w terms to other side. So then taking this term to LHS, then taking out that d as a common term outside the bracket. So what you get is d into xf minus yd star. In the same way, on the right hand side, you get W is equal to XW minus XF. So this term, when it is shifted to this side, it becomes minus WXW. Now, we can arrange this equation in this way. So minus W by D. So shift this D to the denominator. And here it is XF minus YD star. And when you shift this entire term to the denominator, it becomes XW minus XF. So we can write this term as xf minus xw, taking out that negative sign and shifting this negative sign to the right hand side. The final operating line equation for the given operation is obtained like this. It is xf minus yd star divided by xf minus xw is equal to minus w by d. Now this is the equation that represents an equation of straight line on an xy diagram, and the line passes through the point yd star xw and xf. So this quantity, that is minus w by d, indicates the slope of the straight line, and this equation, equation number 3, is called the equation of operating line for flash vaporization. Okay, it is a straight line on XY plot called the equation of operating line for flash vaporization. It has a slope of minus W by D and passes through the point YD star XW on the equilibrium curve as shown in the diagram. So this is the equilibrium distribution diagram for a binary mixture. So you know that X values will be taken on X axis and Y star values on Y axis. So you all know how to construct this diagonal line and the equilibrium line having the equilibrium relationship of Y star versus X. So after construction of this line, so we can locate a point on the diagonal line that corresponds to XF value. Then from this line, if we draw a straight line such that it passes at a point on the equilibrium curve which corresponds to YD star on the y-axis and XW on the x-axis. So this line constructed is the equation of operating line for the flash distillation or equilibrium distillation. The slope of this line will be equal to minus W by D. Now we have finished the understanding of the flash vaporization or equilibrium distillation. Now let us solve a problem on this type of distillation method. So this is a problem that is supposed to be solved now. So let us read the question and understand. So before we apply the equation and solve the problem. It is given that a liquid mixture containing 40 mole percent benzene and 60 mole percent toluene is subjected to flash distillation at a separator pressure of 101.325 kilopascals to vaporize 50 mole percent of feed. So what will be the equilibrium composition of the vapor and liquid? So it is given that a liquid mixture containing two components, benzene and toluene, in a proportion that benzene is present in 40 mole percent quantity and the toluene present in a percentage of 60 mole percent. So this binary mixture of benzene and toluene will be subjected to flash distillation. So also the pressure at which the operation is taking place is given. So 101.325 kilopascals is the total pressure at which the operation is carried out. So this operation is carried out in order to vaporize 50 mole percent of the feed. Okay, so almost half of the feed need to be vaporized in the given operation. So using all this data, you have to find out now XF, D, YD star, XW. So you have been asked to calculate the equilibrium composition of the vapor and the liquid. So you all know that in the flash vaporization, vapor composition is represented by YD star and the liquid composition is expressed in XW. So our aim is now to find out YD star and XW of the operating line that we have derived for the equilibrium distillation. So for the purpose of calculation, equilibrium data is given. So X versus Y values for the given mixture of benzene and toluene is given. So using this, let us now find out what is the equilibrium composition of the vapor and liquid in the separator. So let us assume a basis for this problem to solve. So imagine that 100 kilomoles of feed is entering the flash distillation apparatus containing 40 mole percent benzene. Okay, so benzene quantity is 40 mole percent in the given solution. So F will be equal to 100 kilomoles. Then XF will be equal to 40 divided by 100 equals 0.4. So this is now the mole fraction of benzene in the feed. So also given that 50 mole percent of the liquid is vaporized, means if you are starting as per our basis 100 kilomoles of feed, 50 kilomoles of that feed is vaporized. So vapor contains 50% of the feed. So D is equal to 50 kilomoles. So once you know D and F, you can use the overall metal balance equation to find out the other quantity, that is the amount of bottom product withdrawn. So F is equal to D plus W. So W is equal to F minus D, 100 minus 50. So W will also be 50 kilomoles. Okay. So from since we know F, D and W, we can calculate the slope of the operating line. So which is equal to minus W by D as per the operating line equations that we have derived for flash vaporization. So minus W by D is equal to minus 1 because both W and D are of equal quantities. So using this slope as minus 1, we need to construct the operating line, and using that you can find out the vapor phase composition and liquid phase composition on the equilibrium curve. So the procedure to find out these two values is like this. Construct an equilibrium curve like this using XY data. So you all have already practiced how to construct this plot once you know the value of X and Y. So first you need to construct the diagonal line by taking X values on the X-axis, Y values on the Y-axis. So same scale is to be taken on both the axes, and uh, at a point where the mole fraction is equal to 1, you have to draw a straight vertical line, and at point 1 of y values on the y-axis, you have to draw a horizontal line. So that makes you construct a box like this and join the corner points to get the diagonal line. Then just go on locating x and y values. So for corresponding x equals 0, y equals 0. So the first point will be the origin. The second point, 0.05 x and 0.13 y. So that will come somewhere here. And in the same way, just plot all the values. And if you join all the points that you have obtained by locating, so you will get an equilibrium curve like this. So after construction of equilibrium line, so mark XF on the x-axis. So you all know what is XF, it is zero point 0.4. So zero point 0.4 at zero point 0.4 exactly on x-axis. So you have to mark a point, and that point is your XF. So from that point, draw a straight vertical line until it meets the diagonal line. So once the diagonal line is reached, so mark that point as point F, and from that point, you have to draw this line of having slope minus 1. Okay? So once you know the slope, you know how to draw the line. So measure 1 centimeter from here, and at exactly 1 centimeter, measure one vertical, draw one vertical line having again 1 centimeter. So then join the top of that line to the point located on the diagonal line and extend that line further until it crosses the equilibrium line. So wherever that line coincides with the equilibrium line, so that point is noted. From that point, you can read YD star, the vapor phase composition on the y-axis, and whatever value that you can read on the x-axis is nothing but the liquid phase composition. So that is how we can solve the problem through a graphical method in flash distillation. So the answers from this plot is that the equilibrium liquid phase composition is zero point 0.3 mole fraction of benzene. That means it contains 30 mole percent benzene and 70 mole percent toluene. And in the same way, the vapor phase composition is zero point 0.5. So that means the vapor will contain 50 mole percent benzene and 50 mole percent toluene. So this is the answer for the given problem. So in the same way, you can do the calculations for flash distillation when the sufficient data is provided. Okay, so these are the links where you can watch videos explaining the flash distillation operation or the different methods of distillation. So this is a quick recap of the today's class. So in today's class, we learned that there are three methods of distillation. One is flash distillation or equilibrium distillation. The other one is batch distillation called simple or differential distillation. And the third one is rectification or fractionation. So what is the difference between the three methods of distillation that also we learned? Then we discussed what is meant by equilibrium distillation or flash vaporization and what are the principles involved in this type of distillation and how we can carry out this particular type of distillation. So after that we solved a problem on a equilibrium distillation by making use of the equation of operating line that we derived for equilibrium distillation. So that completes the first session of the methods of distillation. In the next session, I'll be talking about the second method of distillation, that is simple or batch distillation. Okay, so let us go through this a set of multiple choice questions. The first question, flash distillation is a suitable method for the separation of components having very close boiling points which form maximum boiling azeotrope having very wide boiling point which form minimum boiling azeotrope. See, flash distillation, batch distillation, or continuous rectification are the common methods of distillation. So these can be applied only for those systems having a wide boiling point difference between the components. So if you are dealing with some azeotropic kind of mixtures or the mixtures with the close boiling points, that is for which the relative volatility is very less, then you have to take up a special kind of distillation method like azeotropic distillation, steam distillation, or extractive distillation. So for this particular instance, the flash distillation is a right method of distillation for separating the mixtures which have a wide boiling point difference. So option C is the right answer for this question. So which of the following statement is true? Flash distillation is a batch operation. It is a continuous operation. It may be batch-wise or continuous. It is a semi-continuous operation. So flash distillation is that type of operation which is a single stage operation but can be carried out either in a batch-wise fashion or in a continuous fashion. So option C is the right answer for this question. The method of distillation which involve the return of a part of the condensate to the still under such conditions that the liquid is brought into intimate contact with the vapors is options flash distillation, differential distillation, batch distillation, rectification. So if you recall how we classified the distillation methods, there are three distillation methods, the flash distillation and the batch distillation, which is also called as differential distillation, are the one in which the vapor is condensed and taken out as a product, and that part of condensate will never be returned back to the still to contact with the vapors. So it is only in the rectification where a part of the condensate will be sent back to the column or the still to contact the upgoing vapors in order to make it rich in more volatile substance. That is to enhance the separation of the components so the a part of liquid will be sent back to the column where it contacts the vapor. So rectification is that kind of operation. So the answer for this question is rectification. So this is our last MCQ. Which of the following distillation methods is known as a equilibrium distillation? So we know that equilibrium distillation has another name, that is flash vaporization. So flash distillation is the right option for this question. So it is neither fractional distillation, it's not the molecular distillation, it is not the simple distillation. So equilibrium distillation is also identified as flash distillation. So the right answer for this question is option number A. Flash vaporization is a single stage operation, multi stage operation, still operation, none of these. So according to the definition of flash vaporization, it is a single stage operation that may be carried out in a batch-wise or continuous fashion. So option A is the right choice for this question. So with that, let me end the first session. I hope all of you have understood the different types of distillation and what is the basic difference between the different methods of distillation. So with that, let me end the session. In the next session, I'm going to talk about the second method of distillation, that is simple or differential distillation.